Hey guys, so today we'll be focusing on the problem called split array largest sum. We are given an integer array and an integer k. Split nums into k non-empty subarray such that the largest sum of any subarray is minimized, right? And a subarray is basically a contiguous part of the array, right? So with all this given statement, let's get started. So let's say that we are given, I'm going to take the lead code example. If we are given 7 to 5, 10, 8, and let's say that for this given thing, we are given k is equal to 2, right? So there are different ways. We can select this, or we can select this and this, or we can select this and this. So there are different possibilities which we can select this k subarrays, right? With this clear, now let's try to understand how we can actually achieve this, right? Because see, there might be different possibilities. There might be one possibilities if I include this and if I include this, right? And actually this gives me the best answer because this sum will be 18 and this sum will be 7 plus 2 plus 9, 9 plus 5, 14, right? So eventually this gives me a, we need to select the maximum sum out of it. We need to select the maximum. The maximum sum out of it will be 18, right? And that's what we are going to be doing in this given question. So you might think that what about the other cases, right? There might exist other cases also, 7, 2 and 5, 10. So this sum will be 23 and this sum will be 9. So eventually our previous assumption was that we were getting 18, but this time we are getting 23. So 20, this is not a good split, right? This is not a good split. So we want a, okay, yeah, you can eventually think of it as a good split or not, because a good split will always make the whole array, the largest sum will be eventually be minimized, right? That's what I'm going to say over here. So even if we select 7 and all of this remaining, so this will be 25 and this will be 7. How 25? 2 plus 8, 10, 20, 25, right? And 25 and 7, right? So now we need to select the maximum out of here, right? The maximum out of here is 25 over here. And earlier we had 23, we had also seen 18. And out of this, all this given possibility, we had to select the minimum one. And the minimum one over here is 18, right? So I think so. I hope the question is at least clear to you guys, right? Now the way to approach this given question is that I'm going to take a, if you want, you can take a pause over here. The hint is binary search. If you know, I mean, I know you must have watched somewhere, gotten some hint, but in case not, the hint is binary search. You can take a pause over this section and try to understand how we can apply binary search, right? So I'm going to resume. So what might happen is that, see, this sum, we are talking about this sum over here. Let's try to think of the reverse process. We are interested in sum. How do we get sum? We can get sum from this 7, this 2, this 5, 10, and 18. 8. So, right? So what is the lowest, like let's say that for any subarray, what is the lowest sum which you can have gotten? 2. Because this is the lowest value, right? This is one given possibility. I'm just defining the range of any subarray. Let's say that you were doing a selection of any subarrays. You were doing selection of any subarrays. What would be the range? I told you that, hey, you need to ensure that at least one element is included in that subarray, and you can take anything max. So I'm asking you, what is the minimum value of that given subarray and what is the maximum value? The minimum is 2. The maximum will be all of this element included, So what is the sum over here? So sum is what? 25 plus 7, 32, right? So I know my answer, this answer will range between 2 to 32, correct? You're getting it? I know for any subarray select, I know that the sum can range between 2 to 32. What if I can do a binary search on this one? If I am able to do a binary search, that is, I will see that see, 2 is the lowest range, 32 is the highest range. And this is continuous, guys. Remember that for a binary search, for us to apply binary search, the first thing is that it should be in increasing order, right? Increasing or decreasing. There should be a monotonic function, right? And this sub array is actually monotonic, right? It is increasing on this side. This is increasing. So how do we get a hint that we want to apply binary search? Is that the first intuition is the increasing. We can see the monotonicity of this given function. So we know that it's increasing from 2 to 32. That means we can try all sort of possible different values. We can say that what if the subarray contains value of 16? Can we try this or give an option? What would happen if the subarray contains a value of 20? right? Let's say that 16 returns, it's not possible. I'm just telling you, I'm not saying it's true. I'm just telling you that what if the 16 is not possible? That means all the previous element will also be not possible, right? If this is not possible, then odd. So that's why this binary search becomes very intuitive approach, because when we make a decision, let's say that this is a straight increasing line, right? And let's say that when we make a decision at this point that okay, this point is not possible, that means that any previous point which I would have selected will not be possible. Hence, I need to start my search from, let's say that this was x, I need to start my search from x plus 1, right? And our search should go from x plus 1 to the max 1. As simple as that. So with this clear, I think so we can start writing the code. But how do we write the code? This is the most confusing part. So guys, trust me, I'm just going to give you a plain binary search thing, right? So this is the thing which I was going to tell you, that lower element will be the maximum element which is appearing over this nums, and the highest element will be the nums dot begin till nums dot end, right? So we are just taking the sum of begin till end, and after that we are going to do a plain binary search. At any point, if we see that the sum was possible, let's say that key, I'm going to take this example. I did not discuss with you. Let me discuss that. Let's say at any point, I know that sum was possible. X is true, right? I mean, we are able to split this given array into nk different sub arrays such that the split is actually possible, and I'm getting an answer of x, right? So we will try a very smaller split after that. So that for that, if high was over here, I will shift my high at this point, which is mid minus 1, right? Which is exactly what I'm going to do over here. But at the same time, I need to store this answer mid, because this mid has returned true, right? If this हो सकता है कि the mid minus 1 can return me false. So that time we will just exit out of this binary loop, and we would have returned the answer which would have stored mid, right? So this is one thing we need to remember, right? This, I mean, generally saying that if you remember this template, I mean, it's the same binary search, but still I'm saying ki this template is actually pretty much used in a lot of different questions. Now, guys, let me ask you one thing. Let me ask you one thing. Now, the question is actually very twisty, because most of the solution which you see online or provided by anyone actually does not miss something, right? That's why I'm making this video. I do not make video. Let me tell you one thing. I do not make video unless I want to share something with you guys. I found something interesting. That's why I'm sharing with you guys. That's my whole purpose. So what is the interesting thing which I found over here? The thing is that how do we generate the splits? This is the, you can do anything, but generating the splits will be the most difficult part over here, right? Because what might happen is that at each sub array, ठीक है, at each sub array we have to include the exact, see क्या हो सकता है ना कि let's, I will take a very basic example. Let's say that I have A, B, C, D, E, F, right? I have something like this, and I need to check if there exists, let's say that if my I wanted sum to be, let's say that, okay, let's take this only example, right? Let's not even confuse you guys. You might be thinking that what is ABCD? So let's say that for this given, max is what? 10, right? Max is 10. So you might think that, hey, I will start generating the split using this formula, right? I will just start saying ki theek hai, jab tak, as long as I'm able to get a value, I will take a current sum. I will take a running sum. Let's say that running sum. Very bad writing. So running sum at this point, the initial point will be 0. We'll start with 7, right? We'll start with 2. And after that, we encounter 5. After that, we encounter 5. And we know that 9 plus 5 is 14, and it's exceeding the value 10. So we are not going to take that. So that's why we generate one split with this 7 and 2. Right? Let me draw that for you. So that's very simple. Now, after that, what we are going to do is that we are going to start with 5. And again, when we try to include 10, we know that it's exceeding the value. Then we come over here. We stop. So at this point, again, we select 10. At this point, again, we select 8. So this is one possibility how you can generate it, right? This is one possibility. But let me ask you, what would have happened if the max was 18? Max was 18 over here. Let's say that how it would have eventually done. So for max of 18, again, we would have done nothing. We would have calculated till here 9 plus 5, that is 14. And when we try to include 10, this value would have given me 18, right? this value would have given me 18, and I know that this split was possible. This split was actually possible. But how do we guarantee that there are exactly k parts? How do we guarantee that? I mean, you might be thinking that, hey, what this guy is speaking out, right? I might be bluffing out like, hey, but try to understand, guys, one thing, right? Try to understand one thing. Let's say that, okay, I'm giving you another complicated example for k is equal to 2, right? Now, let it be, make it k is equal to 3. So, what might happen is that, let's say that I'm taking 1, 1, 1, 1, and 5. And my max sum is, what you can take max sum? Let's say the max sum to be something like 5. Okay? Now, as simple as that, here you know that you cannot do a split. Why? Because if you try to include these things, these 5 and this 5, the sum would have eventually give me, if I use this rolling mechanism, you see what we were initially thinking. I'll tell you that we were going greedy. We were going greedy, right? And if we were going greedy, we would have kept adding 1, 1, 1, 1, 1 until we have reached the value of 5, right? We would have done that exactly. And after that, we would have encountered that after adding this 5 to the previous one, my max sum actually exceeds the value. My max sum actually exceeds the value. So that's why I cannot do that. So what I will do, I will generate a split. But based on your thing, based on your notion, you would have gotten the count or parts count, right? Let's call this parts count. What will the parts count, guys? The parts count will be 2. This will be 2. Why? Because you have gone greedy, and that's why it's bad. Going greedy is bad over here. Now I will tell you why. What we could have done is that we could still have achieved. So ideally, if part count is 2 and we wanted k is equal to 3, you could have thought that, hey, if parts count is not equal to k, I will return false, right? But no, no. This is where majority of the YouTubers, majority of the people, all who are even copy pasting the solution have gone wrong. And this is what that's why I have made this video, to conclude that the problem over here is that going greedy will give you a wrong answer, right? Going greedy will give you a wrong answer, but there is a twist to it, only if you understand it very well. I know that if the part count is 2, right, 2 is less than equal to 3, obviously. That is, parts count is less than equal to k. But guys, try to think, what are the different parts? This and this, right? You might be thinking that, hey, what this stupid guy is saying. But let's try to understand. Let's not think anything. See, the problem is that if we try to include, if we didn't try to include this last one, let's say that this last one was not included as part of this array, sub-array, could have we still generated something? Yes, we would have. Yes, we would have. We could have eventually used the last element here and said that, hey, do not be part of my part 1 array, go form your own array, and this k will have become 3. I mean, the part count would have become 3. It doesn't make sense, right? If we had done this, but because we have gone greedy, we would have gotten the count as 2 and we would have returned false. So what is a new observation which I can say over here? What is a new observation? Guys, try to understand one thing over here. So if the interviewer, now I'll tell you one tricky part. If you do this greedy kind of approach in the interview, right? And just in case, the interviewer asks you, hey, how will you return me those specific parts which have resulted, like, can you return me the k specific parts which have eventually resulted to count being the max sum being 5? That means it is asking you the combination which have eventually resulted into that. So in that scenario, guys, what will happen is that if you do this greedy approach, that time, if you just do a pushback operation, basically now, if you just do a basic pushback operation, you would end up creating 2 different array, and that time interval will roast you, right? So what we need to do is that any sub array, we know that the part count is less than equal to k, right? This satisfies that means ki there exists one particular part which can be further split down, into 2 different parts, such that my whole max sum will be equal to 5, because यहाँ पे 5 को छेड़ना मत, do not touch this 5. My whole point is that do not touch this 5. whatever was resulting into 5, just let it be 5. Touch all the parts which are less than 5 and try to break it down. Okay, then we are guaranteed. Okay, I'll tell you even this thing. If you're going greedy, the greedy will only tell you one thing, that if you have generated a count of 2 and you are able to split this given array into two parts such that 2 is less than equal to part k, that means you're guaranteed that there will exist k different subarray. So this is a twist in the given question. And if the interviewer asks you like, let's say कि अभी इसमें पूछ दिया तुमसे कि अभी मुझे there are 5 ones, huh? Do not I know ki how difficult it is. My one and comma is same, so my bad. This is something like this. Let it be. So there are 5 ones and let it be that. So the thing is that I'll draw it one more for you guys. 1, 1, 1, 1, 1, right? And this will be 5, right? If you just return this to the interviewer, he will be doomed. So do not do that. What you do eventually do is that take the largest one, take the largest any subarray such that it is less than equal to 5 and it has more parts to it. What you can do is that just ensure that first of all, what you can do is that greedily select any different sub array which is exactly equal to k, which is exactly equal to max sum. Do not touch that. Do not touch that and touch the other array, sub array, which has more parts to it, like elements to it, sorry, and just try to split it down. Just try to split it down. So we want k. This is count for this k. We have k is equal to 3, right? And a count for this thing will be 2. If we split this thing further, we would have gotten 1 comma 1 comma 1 and finally 5. So that's how things are working. So you have to split or you can greedily do even here. You can select the largest sub-array, which was resulting into this. See guys, I have not solved this exact part, but I am giving you the hint. And I am first telling you that why this greedy approach is bad in case if someone wants to exactly return what is the sub-array which have constituted to this k, right? That's why this is a very tricky question to solve. So now I'll just write the code for you. That's why now the scene kya hai ki I will even show you why majority of the people keep blundering these things. They keep. So first of all, let me just type it out. Num size. We keep incrementing. ठीक है, ये पार्ट तो सिंपल है. तो एक कॉर्नर केस लेके चलेंगे कि इफ नम साई इज ग्रेटर देन इक्वल टू मैक्स सम. ठीक है, जो मेरा करंट नंबर ही है, मेरे को एक ऐसा नंबर मिल गया विच इज ग्रेटर देन द मैक्स सम, देन आई कैन जस्ट प्लेनली रिटर्न फॉल्स ओवर हियर, राइट? And the next thing over here is that I will try to include the current sum and see कि मेरा मैं greedy बन रहा हूँ. ठीक है, the whole thing is that I want to be greedy. So let's say that if I am greedy, I will add this, and if it is exceeding the max sum, then I'm going to say कि make the max current sum as 0. ठीक है, make the current sum as 0 and increment the part count, right? The part count, why it is 1? So why we are starting? Because let's say that कि you देखो, तुम पहले टाइम में इटरेट करना चालू कर रहे हो. ठीक है, पहले टाइम में इटरेट करना चालू कर रहे हो, तो फर्स्ट पार्ट यू एनकाउंटर विल ऑलवेज बी 1, राइट? That's how we are iterating over here. So the thing is that the part count will be 1 because you have started iterating and this is your current part, right? So that's why it is 1 over here. And after that we will once we found another element, we are going to the next part. That's why this part has been completed and we are gone to next part. So if your loop breaks over here, what is the total count over here? Part 2, right? 2. If my loop ended at this point, let's say for god knows what reason, I could have easily said ना कि मेरा value ये हो जाएगा, part count की value 2 हो जाएगी. ठीक है, so as simple as that. And after that I return the num sign. So guys, this logic writing is very simple. All you need to take care is the part count all logic. If you are able to, so interview mein you will be doomed because of this part count only. And what you have to ensure is that this part count is less than equal to k, right? If part count is less than equal to k, this will return me true. Otherwise it return me false, and which I have to handle it. But don't you think we have to handle one more case over here? What if the part count becomes greater than k? Yep. If the part count becomes greater than k, we have to return false. And so we do that. Right? Let's see ki if everything has been accounted for, I think so it should work. Let's see. I'm not very much sure. If this works, I am going to submit this video. Just know that. Otherwise, I'm going to re-record myself and just have this again. So it works. So that means I do not have to re-record. Fantastic. And I wanted to show you a bit of solutions which are present on this. Right? They are going greedy over here. Just remember that they are going greedy. So that's why if you have spent some time over here in this section, you will not be able to understand, right? You will not be able to understand because they are just doing the splits, and this is very confusing, right? So most of them, as you can see over here, this part is actually very confusing. They mess up during the is possible level part. So just think what I have explained over here. It will be very clear in your head. Just keep your head very clear, and you will be able to solve any question, right? Always trust yourself. Always trust your instincts, right? You can never be wrong. Maybe it might take for some time you to understand, but you can never be wrong. Okay, that's all.